This is MATHguide.com, and my name is Mark Karadimos. In this video, you're going to check out how to use the product rule for derivatives. We already have a video on the derivation of this rule, this product rule, so I'll put that in the comments section of this video. All right, let's jump right in and let's talk about a function. So let's say I've got a function that's made up of a couple other functions. Like for instance, let's say we've got f of x is equal to, let's say 2x plus 5. And let's say we've got g of x is equal to x squared minus 7. So let's say, for some reason, let's say I had to find the derivative of all this. So I got to find the 2x plus 5 is being multiplied by x squared minus 7. And I want to find the derivative of this whole thing. Well, I'm going to try to do this a couple different ways to get this. So let's say I were to multiply these two together. Okay, if I were to multiply these two together, let's say I get the 2x plus 5 being multiplied by the x squared minus 7. Let's see, I'm going to get x squared times 2x cubed. Let's see, x squared times 5. Let's see, I'm going to get 2x times negative 7. And I'm going to get 5 times negative 7. All right, so this is really what the product is, right? If I were to take the product of these two, I get this. Okay, so if I were to take the derivative of this, right, I just multiplied first, I'm going to use the power rule for all these, right? So I'm going to take the power rule here, it's going to be 6x squared. Power rule here. Let's see, power rule here. And there you go. Take the derivative of that as a constant is 0. So I get that. Well, let's do it the new way. Let's actually use this product rule. So if I were going to find the derivative with this method, it says I'm supposed to write down f of x. It says I'm supposed to multiply that by g prime. So if I take the derivative of this, I get 2x. Now it says take the derivative of f, 2. Multiply it by g of x. All right, let's do a little math. So if I do the distributive property here, I get 4x squared plus 10x. Okay, do the distributive property here, I get 2x squared minus. All right, so let's see. Going to combine some like terms. I get 6x squared plus 10x minus. So there you go. I got the same answer that I would have gotten if I just multiplied them together and took the derivative. So there you go. So that's not a proof. I do have a proof, MathGuide video for a proof, but it demonstrates that using this formula gives you an answer that you would get had we multiplied these two binomials together and then took the derivative. Okay, so it kind of verifies what we're doing is correct, and it gives us a chance to practice some skills. Let's try another example. All right, here's our second example, and what I'd like to do is find the derivative of the product. So in other words, I'm going to take f of x times g of x, and I'm going to take the derivative of the product. Now before we get started using the rule, I'm going to think of this as 3 times x to the negative third. Likewise, for g of x, this is x to the negative first. This is x to the negative second. Okay, so if I'm going to find the derivative of this, what does it say? You take f, all right, here's f, times g prime. So if I take the derivative of this, it's going to be a negative 2x to the negative second. Just using the power rule, right? Taking the derivative of that is going to be a 10x to the negative third. Okay, and what else does it say to do? It says I'm now supposed to put f prime, f prime, which would be negative 9x to the negative fourth, and then times g. Minus 5x to the negative second. All right, and of course, what do you do with these kind of problems? Clean it up. Okay, so let's do the distributive property. So that's negative 6x to the negative fifth. So that's going to be 30x to the negative sixth. Do the distributive property, that's going to be negative 18 x to the negative fifth plus 45 x to the negative sixth. I guess what you could do is you could rewrite this. There's no common, oh, there are actually here. I must have, oh, actually both common. So here I'm going to add these. This is going to be a negative, what was that, 24? Yep. Negative 24 x to the negative fifth. Add these. That's 75 x to the negative sixth. Okay, and what I was thinking earlier is that I can take this and say, oh, that's a negative 24, and put those 5 x's in the denominator. Likewise, I could do this. I could put the 75, and I can put the x to the sixth down there. I could switch these around. Since this one's negative, I could put, anyway, I could play around with this, put this in several different forms, but you're looking at the product rule used on those two functions. All right, so please check out all the lessons, interactive quizzes, and instructional videos that are available on MATHguide.com. Like the video, I'd appreciate it if you did, and subscribe to the channel. Thanks.